Hi guys, it's Andy, the GDScript dude, with another video about coding with GDScript in Godot engine. In this one I'm going to show you how to do some complex debugging tasks. So let's put this into context. Let's start a fairly complex situation. Say no, that's not so complicated, is it? Let's go to this 328 decoder. You can see that this is a fairly complicated scene, and say there's some problem in the nodes, like in this there's like states traversing through nodes which are actually logic gates in this situation, and there might be problems along the way. Like there's a lot of what I call here AND gates, and there's lots of them, so if there was an error in the code, be quite hard to trace which particular AND gate it is. So it's kind of nice to tag them with some kind of label. Let's exit the code and let's look at what we can do. Let's look at the pin scene. So normally a pin is just like that, just a dot, and I've added a label to it which is normally invisible. That will help us to tag it with an ID. So let's look at our code. You can go to scripts, and then I use an autoload script. I usually call it just g.gd, and in there I've added another constant called debug, and I can set it to false or true. So at the moment it is false. If we set it to true, let's see what happens. You gotta type it right, man. True. There we go. Control S to save. Even though when we run the game, it will save it anyway. Let's go again. Let's go there. Let's go to our, what was it, 328 or 77? 328, wasn't it? You can see every pin. Hover over there. There's a pin, and it's got a tag of the number of it. So it's going to help us diagnose what's going on. So on the one hand we have our visual diagram of the scene, and every point of interest has a number, like an ID number, and then in the code you're going to see that we can debug the code based on this ID number. So staying in the global g.gd autoload script, we're going to have a get debug ID function, which will be called by the various scenes to get a new ID, and we're going to keep track of it by incrementing that value there, which will start with 0, and then each time this is called, it gets incremented. It's going to be a global value, so we'll go 1, 2, 3, 4, 5, and so forth every time it's called, and return its value. Now going back to the pin scene, there is a script on there called pin.gd, and in the ready function, when it's instantiated, there is a test, like if the g.debug flag has been set, i.e. in the autoload it is true, this value, then we're gonna assign its internal, there you go, its local debug ID property, which is 0 at the moment. If this is flagged that we want to do some debugging, we're going to give it an ID value which we get from our global script, and it will give it a value, a unique one, which increments every time it's requested. So this is going to be 1, 2, 3, 4 or 5 or whatever. And then we're going to make our label, which is hidden, you can see there, make it visible, and set its text value to the debug ID value. That is an integer, but then we want to cast it to a string value. I'll assign it to the text label. So there you go, we can see it working. We're going to get in any scene, we're going to get the unique value of this ID. Alright, so how do we make use of this for debugging? Well, astute observers of you may have noticed in our output window you've got a series of numbers, and then values of Boolean, true or false. All this is called via a function that is accessed every time something changes in a game that we want to monitor and debug. In this case, I've called it its state changed, and every time something happens in my scene as an input to a pin or a part, it's going to call this state change function. And then I have this test of if g.debug, and remember g is the auto load with its property of debug. If the debug setting is true, then we output to the output window there, we print, and then we use some formatting where it says %3d. That means it's going to insert a parameter from this parameter list separated by this %sign. And 3D means make it at least, no, actually make it 3 digits wide, and D means a digit. So you can see here we got space, space, D8, and space 17, space 14, space, space 7. That is what's going on with this section of it. And then there's a tab. Tab is a /T, like a /T, which means it's called an escape sequence, like pressing tab in your word processor package and making this tab space there. And then %s means formatted as a string. This thing means to follow this are parameters, and then they have to be an array. In this case, we need 2 of them to fill the 2 spaces. One is this digit and the other is a string. So the first one is our debug ID, which is assigned here. You know, it's the value up there, which is a integer. Then, so that is our integer passed to here to make it appear as a 3-digit wide decimal because of that D. And then the state is the true or false, or it might even be a question mark if we didn't supply anything. So this formatting parameter of s means just try to make it into a string. So if it's Boolean, it'll be true or false, and that will be made into the words true or false, which you can see there. Otherwise, it'll be this string of a question mark. So that is how we can kind of debug this. There we go. See that is 1. If I change that, actually, let's do it here. Let's clear this. See, there's nothing in the output now. You click on the clear. Remember, this is going to start outputting stuff because it's in the debug mode. And let's go there. Let's change something. Look at that not gate, number 8. Remember 8? Yeah, this is only going to log the inputs, number 8, and then it should change to the inverse of that and propagate to at least 10 and various other places such as 27. Let's just look at number 10, number 10 logic input. That is low now, so if it registers a change, it will go high. So that is number 10. I'm going to click that. See, there's nothing there now. Let's look at this. Let's click on this, number 10. See, it went high. So let's look for the input value 10. See, it went high, true. That means we can trace what happened. So I'm just saying that is one way I was able to debug this lot, even though before doing this it was just too difficult, right? So these things can come and go. You can put whatever information you like there in labels and so forth just by going to, I'm still playing, so let's stop it, just by editing the value here. The constant of debug is to false or true, depending on what you want to do. So look, if we run it again, we're not going to see any of that stuff again. Not now, anyway. So there you go. So hopefully that was interesting, and see you again in another video.